Magandang araw sa inyong lahat. Right now, I'm going to present to you several problems about DC generators na merong mga voltage drops doon sa mga brushes. Again, yung ating mga brushes, they are used to collect the generated EMF from the armature. And syempre, kahit sabihin natin sila ay mga conductors, still meron po silang mga resistance. At lahat naman ng mga materials meron silang mga resistance. At kahit yung mga conductors, may mga resistance po yan. Kaya nga, kapag dinaanan po ng kuryente yung resistance na yon, magkakaroon tayo ng voltage drop po doon. So, ibig sabihin po, yung voltage drop doon sa mga brushes natin, karagdagang voltage loss doon sa system natin. Maraming klase mga losses yung ating mga generators. Pag-usapan po natin yan doon sa mga susunod na topics, lalo na po doon sa topics about the efficiency. Ngunit right now, yung mga resistance na dinaanan po ng kuryente, sigurado po magkakaroon yun ng mga voltage drops. So yun po. Okay. Lalo na po kung yung generator na yun, hindi lang po dalawa yung brush niya. So meron tayong multiple brushes. So mas madami mga voltage drop po na pwede mapunta po doon. Okay. Kaya nga doon sa ating mga brushes, mas maganda yung pagkakadikit niya, okay, doon, or yung contact po niya doon sa ating mga commutators, nang sa ganun maiwasan po yung mataas na voltage drop. Kasi po kapag masyado naman pong mahigpit yung pagkakadikit or pagkakalagay ng ating mga carbon brushes doon sa commutator, masisira din po yon, mataas din po yung losses doon. And also, kapag naglulus naman po yung contact ng brushes doon sa commutator, mas mahihirapan pong dumaan yung ating kuryente. So, merong nakasukat doon na pressure, amount ng pressure na sapat lang para maging efficient pa rin po yung ating mga brushes sa pag-collect ng generated EMF mula doon sa armature. Okay, so una muna ang lahat, lagay lang po muna natin yung kung paano tayo maglalagay ng equations para doon. I have here a shunt generator, although later on magkaroon tayo ng problem about long shunt din. So we have here the shunt generator. Okay, nandito na po yung armature, nandito po yung generated EMF, tapos andito po nilagay po natin yung VD, or that is the voltage drop. Yung iba nilalagay nila VB para voltage drop doon sa brushes. Okay, so okay lang po yung VD or VB, it's up to you po. Okay, as long as that is recognized as the voltage drop doon sa mga brushes. So nandito po yung armature current, okay, yung ating RA, tapos meron na po tayong mga positive, negative, even doon sa ating terminal voltage, and yan na namin po yung ating IL, load current. Then we have here the shunt field resistance, okay, yung shunt field po natin. Tapos nandito po dumadaan sa kanya yung ating ISH. So nagay lang po natin yung ating mga positive and also negative. So mag-establish muna po tayo dito ng ating node. So still that is node, okay, KCL at node A. Still that is summation of current in is equal to the summation of current out. So dito, we have IA is equal to IL plus ISH. Ngayon naman po, papaano naman po yung ating loop dito? Okay. So sabihin natin that is loop number 1. So KVL at loop number 1, we have there, una muna yung positive EG. Positive EG. Now, pagdating po dun sa voltage drop across dun sa mga brushes natin, we're going to have there, negative po siya. Okay? Naibabawas po yung voltage drop doon sa ating mga brushes. So that is minus VT. Then, there we have the negative RA. Multiply natin ng kuryente para maging voltage. IA times RA. Then, punta na tayo dito sa loop natin. We have negative VT equal to 0. So, yun na po yun. Ito na po yung ating voltage drop doon sa mga brushes. Ngayon naman, kung yung problem na specify po siya na dalawa po, okay? So sabihin natin, iba yung voltage drop dito, iba yung voltage drop doon. Although dapat pareho lang po yung kanilang value, okay? Sasabihin dun sa problem, each brushes has a voltage drop off. So yun po yun. Okay, so maglagay lang po tayo ng ng isang okay, no, mag-solve lang po tayo ng mga several problems concerning that. Okay, so dito, a shunt generator supplies a load of 20 kilowatts at 400 volts. So yun yung terminal voltage, yun yung power output. The armature and shunt field resistances are 0.13 ohm and 85 ohm respectively. Assume a brush contact drop of 1 volt per brush. So meron po siya nung per brush. Okay, determine the generated EMF. So drawing po muna natin yung ating diagram para sa ating generator. So pasensya na lang po dun sa ating drawing. Yan. So we have here yung ating EG. Ito po yung hinahanap po natin. Tapos, meron tayong voltage drop dito, 1 volt per brush. So, this is 1 volt. So, sabihin natin that is per brush. Now, we have RA. Meron tayong 0.13 doon. 0.13 ohms. Tapos, yung ating shunt field resistance is 85 ohms. Then, we have the power output. This is equivalent to 20 kilowatts. Tapos yung ating terminal voltage, that is 400 volts. Yan. So meron tayong mga generators, negligible na po yung voltage drop doon sa mga brushes natin. Kaya may mga problems tayo, hindi na natin ini-involve yung mga voltage drops doon sa carbon brushes. Yan. So meron tayo ditong IA. Now, we have here the ISH. Tapos, nandito naman po yung ating IL. Okay. So, pwede na po akong unahan sa pag-solve if you have already watched yung mga naunang videos natin po concerning yung mga shunt generators, long shunt generators, short shunt generators. Okay, so, let's try to solve this one. So mag-establish tayo dito ng isang loop. So that is loop number 1. Okay, that is in order to determine the generated EMF. So KVL at loop number 1, we have their positive EG. So minus. Ang sabi po kasi dito, per brush po yung 1 volt. So, ibig sabihin po, dahil dalawa po, assuming na dalawa yung brushes natin, so meron tayong 2, multiply that by the VD. Okay. Next, minus IA times RA, tapos minus yung terminal voltage, minus VT equal to 0. So, wala pa po tayong EG. Ito po yung unknown. So, meron tayong 2 times, that is 1 volt, minus IA, wala pa po tayong given for IA, pero later on, mahanap po natin yon. We have 0.13 volts for RA, then minus 400 volts equal to 0. Bakit parang mas pangit ngayon sulat ko, no? Okay, anyway, we have here EG, minus 2 volts muna. Okay, minus IA times 0.13 volts minus 400 volts equal to 0. So parehong negative yung 2 volts saka yung 400 volts, mag-add po yan. We have EG minus IA times 0.13 volts minus 402 volts equal to 0. Okay? So, hanapin po muna natin yung value ng IA in order to determine the value of our generated EMF. Yan. To establish the node here, okay, so KCL at node A, again, that is IA is equal to IL plus ISH. Next, meron na po ba tayong value ng IL? Siyempre, wala pa po. Pero yung formula natin for that one, IL, that is power output divided by the terminal voltage. Okay, given po yung power output, given din po yung ating terminal voltage. So, plus ISH, again, the shunt field is connected in series with our terminal voltage. So, we have there VSH muna dito, no? Divided by RSH by using Ohm's law. But again, ito po ay VT po yon dahil konektado po in parallel yung ating shunt field and terminal voltage. Okay, so IA is equal to, the power output is 20,000 watts, or that is 20 kilowatts divided by 400 volts. So plus 400 volts divided by 85 ohms. Therefore, IA, solve lang po natin. So we have 20,000 divided by 400, then plus 400 divided by 85. This will give us 54.706 amperes. Na pwede na po nating i-substitute dito sa equation na to. So, we will be having EG. Okay, pwede na po natin itong mga to, ilagay na po natin sa kabila. So, that will give us positive values. Equal to, okay, transpose na po natin sila, IA times 0.0, okay, sorry. That should be 0.13. Okay, plus, positive na po tayo doon, 402 volts. Okay, this is 54.706 amperes times 0.13 ohm plus 402 volts. Therefore, EG is equal to, so 54.706 times 0.13 plus 402 volts, this will give us 409.112 volts. So, yan na po yung ating sagot. Okay, so let's try another problem here. Yan. Ngayon naman po, that is a compound generator. So, a 5 kilowatt, 120 volt compound generator has an armature resistance of 0.23 ohm, a series field resistance of 0.04 ohm, and a shunt field resistance of 57.5 ohms. Assuming a long shunt connection and a voltage drop at the brushes of 2 volts, calculate the generated EMF at full load. Now, drawing po muna natin yung ating figure. Diagram po natin dyan. So, we have there a long shunt. Yan, okay. So, terminal voltage is equal to 120 volts. Then, the power output is 5 kilowatts. So, nandito po yung ating IL. Positive, negative ng terminal voltage. Meron tayo dito yung EG, yun po yung hinahanap natin. Ngayon, meron tayo the positive and negative brushes. Ngunit meron siyang tinawag na a voltage drop at the brushes. So, brushes of 2 volts. So, ibig sabihin po, yung total voltage drop na po sa ating mga brushes ay 2 volts. Hindi po katulad dun sa isang problem kanina, binanggit po niya each po. Okay? So, merong isang voltahe per brush po kanina. So, it is also the same with this one kasi sinabi nga niya voltage drop at the brushes of 2 volts. So, assuming that that is 2 brushes, so ibig sabihin 1 volt per brush po yung losses natin doon. Okay, we have here the RA. Ang RA po natin is given as 0.23 ohm. Then the series field resistance is 0.04 ohm. So we have their positive and then the negative. Ito po ay meron siyang 57.5 ohm. Ngayon, yung mga direction po ng ating kuryente. So that is positive, that is negative. Okay, nandito rin po yung ating IA. Now, again, to solve this one, gawa po tayo dito ng isang loop. So, this is loop number 1. We have their KVL at loop number 1 that will give us positive EG pa rin po. The next, again, voltage drop po ito. Kaya that will be negative VD, then minus IARA minus ISE-RSE. Okay, dito po yan. Yung kuryente po nadadaan doon sa ating series field resistance. Then, pupunta po tayo dito, we have negative VT. So, minus VT equal to 0. Yan. So, itong ISE po, that is also equivalent to IA dahil sila po ay connected into series. Okay, so simplify ulit po natin ito. EG minus VD minus IARA minus IA times RSE minus VT equal to 0. So kunin po natin itong dalawang to, no? Factor po natin yung negative IA. We have EG minus VD minus IA, multiply that by RA plus RSE. So, finactor out po natin yung negative IA, kaya meron po tayong positive RA plus RSE. So, minus VT equal to 0. Yan. Ngayon, lagay po natin mga given, VD minus the 2 volt na voltage drop minus, wala pa po tayong given na IA. We have here RA. RA is 0.23. 0.23 ohm. Tapos plus 0.04 ohm. Then we have there VT is 120 volts equal to 0. So simplify po natin muna, no? Itong dalawang to, negative 2 volts minus 120 volts. EG, okay, minus 122 volts. Minus, we have there IA times, this is 0.27 ohm equal to 0. Yan. So, pwede na po natin i-transpose kabila. Lipat po natin sa kabila, magiging positive po sila. We have EG equals positive 122 volts plus IA times 0.27 ohm. So, ito na po yung isang equation natin. Then, wala pa po tayong value ng IA, pero makukuha natin yan by using nodal analysis. So, maglagay po tayo doon ng Kirchhoff's current law dito, okay, para sa node KCL at node A. There we have IA is equal to IL plus ISH. Yan po. Okay, so we have here, again, the formula for our IL. IA is equal to, formula for IL, dito po, we have the power output divided by the terminal voltage. So, PO divided by VT. Ngayon, paano naman po kay ISH? This is long shunt, therefore, yung terminal voltage po is equal to the voltage across the shunt field winding. So, ibig sabihin, this is plus VT over RSH. Ngayon, lagay po natin yung value po ng power output natin is 5 kilowatt. 120 volts naman po dun sa ating terminal voltage. So, 5,000 watts divided by 120 volt plus 120 volts divided by value po noon is 57.5 ohms. Okay, therefore IA is equal to, so 5,000 divided by 120 plus 120 divided by 57.5. So we have here 43.754 amperes. Yan. Na pwede na po natin i-substitute dito sa equation na to para makuha na po natin yung value ng EG. Okay, so EG is equal to 122 volts plus 754 amperes. Multiply that by 0.27 ohm. Therefore, the value of EG is 122 plus 43.754 times 0.27 will give us 133.814 volts. So, yun po yung ating sagot. Ngayon. Okay, I'll be leaving you one problem. So, pwede na pong i-pause yung ating screen. Yan po. And try nyo pong isolve itong problem na to. Okay. Salamat po.